All right, so this is a problem right here where I can use the oldest strategy in the book for comparing any set of fractions. I can find a common denominator for all these. This is what you would ideally like to do all the time. It doesn't always work this way though. So if I look at these, I've got a denominator of 4 and a denominator of 6 and a denominator of 3 and a denominator of 2. Now all of these are mixed numbers because they also have a whole number, but make no mistake about it, the whole numbers are all the same. So this is really a problem about comparing fractions. The whole numbers really don't make a difference here. I still have to write them, but they're really not going to make much difference. So if I start thinking about it, I always start with the largest number, 6. Well, 6 times 2 is 12. Yep, 4 times 3 is 12. 3 times 4 is 12. And 2 times 6 is 12. So all of these can get a denominator of 12. So if I just go through, so I'm going to start this way. I've got 7 3/4. I said I would be multiplying 3/4 by 3 over 3. And I get 7 9/12. Okay. If I've got 7 5/6, if I multiply that by 2 over 2, I get 7 10/12. If I've got 7 2/3, I said I'd be multiplying that by 4 over 4. And I get 7 8/12. And then my final fraction, 7 1/2. If I multiply that by 6 over 6, I get 7 6/12. Now then, all of these fractions have the same denominator. So they are incredibly easy to compare now. I've got 9/12, 10/12, 8/12, and 6/12. So I'm making them from least to greatest. Very, very, very simple. So the smallest one is 6/12. So the smallest fraction is 7 1/2. So I've got rid of that one. Now then, 8/12 is the next smallest. So the next smallest is 7 2/3. My next smallest, 9/12. So that would be 7 3/4. And then finally, the largest, 7 10/12. So that would be 7 5/6. So I now have my fractions in order from least to greatest. And I did it by just getting a common denominator for each one. Okay, very, very, very simple. Now, I said that, and I also said it doesn't always work. So I might perhaps have a problem where I can't do that. So let's say that I've got like this. We'll try, let's say I'm going to go, again, I'm going to do least to greatest. And let's say that I've got, well, these are all mixed numbers beginning with 2. Let's say I've got 2 3/4, and I've got 2 3/8, and I've got 2 3/7, and I've got 2 3, we'll say 13ths. Why not? Okay. Really, with these denominators down here, if I'm looking at these, I've got a 4 8, a 7, and a 13. Well, if I do 13 times 2, that's 26. None of the other ones equal that. 13 times 3 is 39. None of the other ones equal that. 13 times 4 is 52. Well, none of the other ones really equal to that except for 4. So this one is going to be almost impossible to find a common denominator. Okay, but I've got some other strategies. One of my other strategies would be that I have the same numerator. on every single one of these. Now, this also works also. This is something that always works. So if you just think about it, since the numerator is the same, the one with the smallest denominator is going to be the biggest. In other words, 3 pieces out of 4 pieces is going to be a whole lot larger than 3 pieces out of 13 pieces. So if you cut a pizza into 13 slices and you only got 3 of them, that's not much pizza. If you cut a pizza into 4 slices and you got 3 of them, well, now we're talking. You got a lot. So on fractions that have the same numerator, the one with the smaller denominator is always going to be the largest. So very, very simple here. So the smallest one is going to be 2 3/13. The next smallest one is going to be 2 3/8. Getting a little bit bigger, I go to 2 3/7. And of course, the largest one is 2 3/4. So if you look, my denominators down here, I'm putting the denominators, the largest denominator would go first. Now, let me tell you this only works with the same numerator. So this is what I would call the same numerator trick. In fact, let me label it. This is the same numerator. Okay, so there's a couple of ways that you can take problems that involves ordering fractions and put them in order.